Welcome to today's Explainer. Today, we're demystifying the rise of AI robotics in extreme environments. We hear so much about the seamless, flawless perfection of modern technology, but today we're actually going to explore the messy, deeply human reality behind these technological triumphs. We're going to see exactly how we got from the dirty, chaotic reality of the past to the pristine promises of the future, and what all of this really means for the human workforce of tomorrow.
So here's our quick roadmap for today. First, into the danger zone, then the dirty robotic history, followed by conquering the extreme. After that, we'll dive into the human element and finally wrap things up with powerful collaborators. Let's get into it.
Into the danger zone, the pristine promise of AI robotics.
So let's start with the big, modern, idealized goal of robotics. The core promise here is incredibly clean, right? We're talking about machines working 24/7 without breaking a sweat, tackling hazardous environments, and delivering flawless precision where a human would almost certainly get hurt. And of course, over time, this is all designed to dramatically lower operational costs. I mean, it sounds absolutely perfect. A flawless technological shield between us and danger.
Section 2, the dirty robotic history, 321 EOD, and the wheelbarrow robot.
But to really understand how we arrived at this pristine promise, we actually have to pivot sharply into the messy, frustrating history of how these machines evolved, specifically during the Troubles in Northern Ireland. We're grounding today's explainer in a really fascinating piece of peer-reviewed research from Queen's University Belfast. What's brilliant about this is that it lets us impartially examine the British Army's use of early robots as a pure sociological case study in human-machine interaction. So we're looking at this completely separate from the political conflict itself, just zeroing in on the raw friction of early innovation in a high-stress environment.
When you contrast the myth with the reality, it is kind of mind-blowing. The myth sells us this story of seamless technological triumph, but the dirty reality? Oh man. It involved intense mechanical failures, totally unpredictable physics, and a very public, unruly spectacle of bomb disposal. Instead of a flawless shield, these early robots were doing things like literally dropping explosive charges or just awkwardly tipping over on sidewalk curbs. It was a deeply turbulent learning curve, for sure. And this definitely wasn't cooked up in some pristine Silicon Valley lab. We're talking about frantic, trial-and-error innovation. In March 1972, they literally purchased a battery-powered garden wheelbarrow. By October of that same year, a prototype was already being deployed in live, incredibly dangerous scenarios. Just 3 years later, in 1975, they had the Mark 7 version running, complete with interchangeable parts like claws and cameras. It was rapid, it was improvised, and it was highly, highly experimental. And the human stakes behind this rapid timeline were massive. Listen to this quote from ammunition technical operator Steve Smith. "The last thing I wanted to do was get the big green suit on and go wandering down to look into the mouth of the dragon when it could still wake up and breathe fire all over me." That really hits home, doesn't it? It perfectly captures the raw fear these operators faced. They were desperately trying to make these clunky robots work simply because the alternative was putting on a heavy suit and walking straight toward a live explosive. You know what's really wild, though? It's how the operators reacted to all those mechanical failures. Even when the machine went rogue and got tangled up, the humans actually formed an intense, almost maternal bond with it out of sheer necessity. They affectionately called those early prototypes a baby, connected by an umbilical cord of control wire. They were basically trying to humanize a machine that constantly frustrated them by not being human enough.
All right, Section 3, conquering the extreme, the modern hazardous deployment.
Having learned from all that dirty history of trial and error, let's fast forward to today. Different industries are custom building some truly unbelievable robotic solutions. In nuclear decommissioning, you've got Boston Dynamics' Spot robot using its 4 legs to navigate rough terrain for 3D radiation scans. In mining, massive autonomous haulage trucks are virtually eliminating fatigue-related human accidents. And for disaster response, we've got robots like the Sakura Explorer, literally built with a heavy bottom plate to shield its electronics from radiation, just so it can navigate 53-degree flooded stairways at Fukushima and spare human repair crews. Let's actually zoom in on the Sellafield nuclear cleanup for a second. It's one of the world's most complex nuclear legacy sites. This is where we see the modern realization of that early wheelbarrow robot's original goal, getting humans completely out of the hazard zone. By using that Spot robot for routine inspections, workers no longer have to wear those complex, heavily stressful air-fed plastic suits in highly radioactive areas. And the tech is moving incredibly fast. In fact, in 2025, Sellafield achieved an industry first.
A customized spot robot was securely operated from completely outside the boundary of the nuclear license site. This remote capability is just a massive leap forward. It proves that those messy physical umbilical cords from the 1970s have finally truly been replaced by seamless, secure teleoperation.
And there's a very tangible value attached to the safety. $50,000. That is the estimated value of human radiation dose averted in just a single 30-minute routine robotic inspection. I mean, that is a stark, powerful number that proves exactly why taking the human out of the hazard zone is absolutely critical.
Which leads us to Section 4, the human element, bridging the gap through upskilling.
Now, you might be thinking, what happens to the workers? Migrating these dangerous tasks to robots doesn't actually mean leaving humans behind. Take Rio Tinto's autonomous mining operations, for example. They use virtual reality sandboxes and digital twins, which are basically exact virtual replicas of real-world sites, so operators can safely experience the sheer scale of 85-ton driverless machinery. Workers can even train for severe emergencies, like underground fires, without ever inhaling a single breath of smoke or risking injury. It's an incredible human upskilling effort.
Because integrating over 130 autonomous trucks isn't just a simple software update, right? It takes a deliberate multi-step strategy. Step 1 is having open career conversations with any potentially impacted employees. Step 2 is actually rolling out those VR and digital twin training programs we just talked about. And Step 3, this is crucial, involves partnering with governments and schools to offer recognized automation qualifications, making sure these workers have real, transferable skills for the future.
2,000. To put that strategy into perspective, 2,000 is the number of individual career conversations Rio Tinto held with their employees in 2019 alone. It's living proof that successful automation isn't just about the robots. It puts people at the absolute center of the change.
And finally, Section 5, powerful collaborators, the human-machine synthesis.
Ultimately, bringing AI into our most dangerous spaces is not a story of human replacement. It's a story of powerful collaboration. We're establishing a very clear division of labor here. While robots handle the radioactive, the repetitive, and the explosive stuff, the roles that require deep human judgment, complex creativity, and emotional intelligence, those remain firmly in human hands. From the stressed, terrified bomb disposal operators in 1970s Belfast to the highly trained, VR-equipped miners of today, human ingenuity has literally always been the driving force behind these mechanical lifesavers. So as we wrap up this explainer, I want to leave you with this final question to ponder. As robots increasingly conquer the most extreme, hazardous corners of our world, are we ready to embrace our new role, not as operators in the danger zone, but as architects of a safer, human-machine future? Thank you so much for joining me today, and keep questioning the incredible world of innovation around us. See you next time.